learn. Today we are going to learn about modularization. It means writing perform statements. Okay, this is part of modularization. So what exactly is modularization? For example, we have a requirement to perform. Okay, um, to perform addition. If you see, for example, no. If you see some codes, there will be a code which is around 100 to 200 lines of code. Just nominal, we have more number of lines also, but there is a very big program is there. And if you want to debug that program step by step, then it will take some time for you, right? The first thing is, if there are no proper comments in the program, it is very difficult for us to understand why he written it, in what sequence he written the program. Okay, that is one problem. That's why commenting a program is very important, like providing comments in each and every step what we are writing is very important to for understanding point of view for other people. In the same way, when we are writing the code, if we keep on writing the code line by line, sequential without any blocks, it is very difficult for anyone, either in debugging mode also. Okay, and when we practicing any example, say for example, I use it to say, this example we are going to do now, like this is what is our requirement. I always say in that way. For example, if I given if I am writing a program for addition of some numbers, what I will say first, I will tell you what I am going to do, like defining two numbers. Okay, and then write logic for the addition. Okay, for example, if I want to fetch data from a table and display on the screen, then I always say like, okay, define the structure table and then write select statement. Okay, like nothing but fetching data from table, and then write the display it on the output screen. It means we can able to what I can say, define the steps what we are going to perform in the program. Okay, steps means either it may be step by step, or we can group multiple steps into one particular subject line. Okay, so defining structure, it is not one single line of code in our program. Defining structure means we need to define internal table, we need to define we need to structure internal table, work area, and all the local variables we need to define. It means it's the block of code. Okay, fetching data from the table means, yeah, we writing the select statement and then checking if the select state, if not only one table, right? If a requirement is to bring data from multiple tables, then you need to write multiple select statements. So it means that is also one block of code. Displaying on the out screen means you need to write the loop statement, or you need to fill the internal table with all the required data and then displaying on the output screen. This is also not single statement, a block of statements. So instead of writing all the code one line by line continuously, we can make the code into blocks. Okay, this is called as nothing but modularization. So what is the benefit of making the blocks, blocks of code? Is, for example, if you are facing problem in the fetching statement, then direct fetching a step in this block. If you are facing some problem, if some table is not getting any data, your table is not filling with proper information, you can directly go into this block for the debugging. Instead of debugging from the start, wherever you are facing problem, you can directly go to that block. Okay, which saves some time, instead of pressing F5 on each line. Now we will see in detail what exactly I explained now. So for example, what I did, perform addition. So my requirement is to perform addition, subtraction, multiplication. Okay. So now in order to perform this, I need two numbers, right? So I am going to define two numbers. Okay. Either I can give parameters for the selection screen, or I can hard code it. So here I am going to give p underscore a type I, p underscore p underscore b type I. That's it. These two variables I'm going to define, and then data to lv underscore sum type I, lv underscore subtraction type I. Let's take all integers only at this point of time. Division type I. I define three variables to calculate these three values and store the output value. Now I am going to perform addition. So generally what we do to perform addition, either I can write simply lv underscore sum is equal to p underscore a plus p underscore b. Okay, so lv underscore subtraction is equal to p is equal to p underscore a minus p underscore b. Similarly, division is equal to p underscore a divided by this one. And finally, I want to write this output on the output screen. So I am going to write the output statement of write lv underscore sum subtraction and division. Okay, in order to get data on a separate line, I am using new line operator here. Okay, so this is some very minimal, small code just which is written in sequential steps. Okay, now I will show you how we can make this program as a modularization. Okay, perform addition subtraction. So to understand you, okay, this in this way we can do do this modularization. I will try to explain you. So this is the code. Now what I'm going to do is a declaration. We always do it on the top. Okay, all the declaration topics, you can define the variables in middle of the program also. There is no problem. For example, if you write here data statement, there is no issue at all. lv underscore, for example, mod type, I. You define it here. There is no problem. Okay. If you click on check button, system doesn't throw any error message, even if you declare the variables on the in middle of the program also. But it won't looks good. Okay. To make our code a little bit cleaner and a nicer way, it is recommendable to define all the variables on the top. This is one of the recommendation we follow here. Okay. So declaration part is the first module, we can say. After that, I want to perform some, right? So what we can do is we can write a perform sum. Okay, and then we can write a perform subtraction, perform division. Okay, perform display output like this. Okay, so here you keep on writing the code one by one. By checking the code means by understanding, people who can having ABAP skills, by seeing this program, okay, a is equal to something, sum is equal to a plus b. Now by understanding this code, they can say you did addition, and by going through it, understanding the code, they can say you did subtraction, you did a division, and then you are writing it on the screen. People who are having ABAP knowledge, they can tell you what you did. Okay, for example, any non-IT background person came here and now checking your code. Now tell me, he can able to tell what you written here, right? Because you clearly mentioned perform sum. It means you are doing summation, perform sub. Okay, you are doing some subtraction. So by seeing this perform, so they can able to understand. Okay, at this point of line, you are doing summation, subtraction, division, and displaying on the output screen. That is how modularization helps you people to understand the piece of code we written. Okay, IT people can understand even whatever complex logic you written, cell statements and all everything, but using this, if you are giving some proper namings to your program, then it will be very helpful for people to understand. Okay, so that's it, not more than this. So now perform is one kind of modularization technique which is used to divide the code into multiple chunks of pieces. Okay, so perform sum is the name of the perform you are writing. So how to define, this is only the definition, declaration of the perform. You need to write the logic inside this perform. How to write inside means double click on this sum, then system will ask you subroutine sum does not exist, do you want to create the object? Click on S button. So when you're creating S button, yes, save the program. Now when you are creating the subroutine, system is proposing two options to you. Either create the subroutine as a separate include. Okay, include topic we not yet covered, we will see later. Or include the subroutine in the master program, means whichever program you are in the same program, it will try to create the definition for this perform. So I am using the second option now and clicking on OK button. So now see what happened. So whenever you see there was some lines of code populated in our program, same our program. At the end of the program, you see this is the program which we written so far. It went to the end of the program and it given some syntax for us to write the definition. Form sum. Perform sum is the declaration part, and then form sum and the form must end with end form. This is called the definition. Okay, here in between these two we need to write our logic. Okay, in the logic what I am going to write lv underscore sum. So instead of writing it on the sequential code, I am putting this sum operation in my within the form. Okay, now click on check button. So okay, these are not there. Fine. Similarly, I am going to create the subtraction perform also. Same kind of operations, creating another form within the same my program and keeping my logic in this form. Similarly, perform division. And finally, display output. I'm going to write these three write statements on the display output. Pretty printer, check, activate. So system will always try to execute the code sequentially when you execute the program. So what happened? So if I'm executing this program now, I'm giving 10 and 20. I will show you how exactly it is working. Okay, 30, 10, because subtraction, division, whatever it may be. Now I'm going to debug this program. So how I'm going to debug? I'm going to put my breakpoint on the starting statement, 17th line. Okay, and then executing my program. I'm giving 20 and 10 and clicking on execute button. Now system came to this perform step. Now this is a perform is a module. So what will happen? It will sorry. It will try to check the definition for this perform. So when you press F5, it will go to the definition. I'm pressing F5. So you see it jumped to 30th line, 31st line, form sum. So now whatever logic is there within this form, it will perform this logic, addition of these two numbers, and keeping it on the output screen. 30. No, sorry, keeping it on the variable lv underscore sum. After completing this form, it will again go back to the next. Means because and it reached to end form is there. Now it will jump back to the earlier statement. So this particular perform was finished executing. Then it will try to perform the sub. When I press F5, again it jumps into the definition of the perform sub. You see, and then try to execute the code which written here. After completing, again jump back to the next statement of perform division. It jumps to the division perform, execute the code written in that block, and then come back. Finally, display output also it will jump, and then it will perform the code written in the display output, and finally after doing it, it will try to come back. But after coming back, there are no further statements are there, so it is the end of the program. Okay, so this is called modularization. This is a very simple program which explains how we can do modularization in our program. But this perform syntax is not yet over. Still we have a lot to understand about perform. because in real time or when you see any existing SAP standard codes in some of the customer exits or some of the function modules, then people write perform in a multiple ways. Okay, multiple means syntax, we can extend the syntax in further way. Okay, perform above statement. So when I press F1 on the perform, is that I'm getting the system help, and if you see here, this is the perform statement. So perform and then perform name. There are some more options out there. And you see, did not implement in function modules and subroutines something. Means in function modules, I think you are not supposed to use the performs and all. Okay. But one more thing, what note, subroutines are obsoleted, do not create further. Better to have some knowledge on it, but it is subroutines are obsolete. Do not create new subroutines in the new programs. Methods should be used instead of subroutines created in existing programs for internal modularization can continue to be called. Whenever possible, however, external subroutines calls from other programs should be avoided. So SAP recommending don't write performs anymore. Go for methods. Method is nothing but it's called OOPS concept, like creating classes and methods. Okay, it means if you have something like this, create a class and define the methods and then try to call those methods instead of going for the subroutines. That is what is here SAP is trying to say. What happened? What is this? Why I'm getting this one? So subroutine. So in this case, but still as I need to explain, 1 second. So far we learned about performing sum using two variables, right? So now we are going to extend this perform operator a little bit. So perform sum, I am extending this perform syntax with a few more keywords. Okay, using p underscore a. No, not like this. So I am going to define two more variables here. 1 minute, not with yeah, okay, yeah, okay, using p underscore a, p underscore b. So you see what I'm doing, perform sum means perform the sum operation using these two operators. I'm telling that like the meaning of the syntax is this one, using p underscore a, p underscore b. So what will happen if I write this using a keyword after in the perform statement? If I try to I'm trying to save my program and let me comment this display. I will write it later. Click on save button and now click on perform operator. Incorrect cursor. Save. Perform sum. 1 minute. So now what I'm going to do, I'm extending this perform statement using using keyword lv underscore a and lv underscore b. What it did, I parameter statements.
Okay.
So perform sum. So perform sum using what I did, I removed this parameter keyword and redefined two local variables. Okay. So now what I am going to do, I am assigning some value lv underscore a is equal to 20 and lv is underscore b is equal to 10. Okay, I am using this one. Now what I am doing, I am writing a perform statement with the using keyword and I am passing these two variables lv underscore a and lv underscore b as the input to this perform. What exactly it is nothing but I am passing two variables as an input to this perform. Earlier we written simple perform, okay, executing the operation. This time I am passing some inputs also to this perform. When coming to the definition of this perform, the earlier it is a simple form sum and then end form, but now because we extended this keyword with using, now here it will comes with using, and whatever variables we are passing here, this particular form definition must receive the values. It means the LV underscore A, whatever I am passing from this statement, must be received by this particular form definition. So that's why I defined P underscore A variable of type integer. So we need to define the data type of the data type of the incoming parameter also. Okay, like this. And then one more parameter is coming here, P underscore B type I. So like this, I need to define my form definition. And within the form, simply I need to write the code LV underscore sum is equal to P underscore A, because the receiving parameter is now P underscore A. Whatever 10, 20 I am sending here, that will come and store in my receiving parameter P underscore A. So now P underscore A is nothing but my value 20 here. Okay, plus P underscore B. Okay, finally, I'm done with this one. If I write simply here write statement, write LV underscore sum on the display output. Now let's see what happened. Execute, that is coming. So let me debug this program. So I'm giving my breakpoint here and then executing. I'm going to LV underscore A is equal to 20, LV underscore B is equal to 10. So now this particular statement is going to execute. So before it is executing, currently LVA contains 20, LVB contains 10. When I press F5, it comes to the definition of this form. Now you see in the form, it contains one input parameter P underscore A, which is equal to the value coming from here, and P underscore B contains 10, which is the value we are sending from the definition, from the declaration. So now this P underscore A and B will be summed up and then added to the sum value. And then when it is returning, I am printing this output on the output screen. Okay, so this is how this perform works. So I am stopping, explaining perform by this time. So this is all about. So we have something like changing keyword also in the perform, which also works in the same way. Okay, I am not explaining that part. So let's go jump into the next topic. Okay, but the perform is one of the important just because not we, as SAP said, we are not supposed to use it in coming, when you creating a new things, new programs, but in order to understand the existing programs, and having the knowledge of perform is important. Okay, I'm stopping recording.